This video is going to go over how to add and subtract rational functions, rational expressions. So remember, we are looking at fractions that contain polynomials. We've got variables of different degrees and with different exponents. And remember, we always have to keep in mind with rational expressions that there are these excluded values in the denominator when x, a value of x could make it equal 0. We are not allowed to divide by 0. So anytime we're talking about domain restrictions or excluded values, that's what we're referring to. All right, so remember, with adding and subtracting just fractions in general, traditional fractions, if I were going to add 1/3 plus 2/3, I would just simply combine the numerators, 1 plus 2, and make that 3/3, which would reduce to 1. Right? We do not combine the denominators as long as those denominators are already the same. We just combine in our numerators. Okay, so the same is true for rational expressions. We combine like terms, right? Like terms, so that means x's with other x's, x squared with x squared, and numbers with numbers. Okay, when we are adding, we can take the terms with the signs as they are. So for this problem, I have 5x plus 1x, which would just be 6x. And then negative 18 plus negative 6 would be negative 24. All right, and that is still over 3x. All right, now with this, which is different from multiplying and dividing, notice we did not factor to begin because our denominators were already the same. We just went ahead and added to condense down to one rational expression. Now that we just have a single expression, we can factor. So I would look for anything that might factor. The only thing I could do is take out a greatest common factor of 6 in the numerator. And if I factor a 6 from 6x minus 24, I get 6 parentheses x minus 4, and then that is still over 3x. And the advantage of doing that is I can then see I have 6 over 3, which would reduce to 2 over 1. So my completely simplified answer would be 2 times the quantity x minus 4 over a single x. Sometimes you'll see that distributed out. If that were the case, it would look like this, 2x minus 8 over x. Sometimes you see it left in factored form. For our purposes, we're usually going to keep it in factored form. In the second example here, we have a denominator that they're both the same already, but they do have a trinomial in the denominator. So in order to determine our excluded values, we would have to factor this denominator into two binomials, right? So we know that in order to multiply to x squared, we have to use x times x. And then the two numbers that would multiply to 12 but add to 7 would be 3 and 4. And obviously this denominator would factor the same way. So we have x plus 3, x plus 4, which would mean that in our domain, the x values are not allowed to be negative 3 or negative 4, because both of those would make one of the factors 0. So now that we've determined that we've factored our denominator, we can go ahead and combine our numerators since the denominators are the same. So I have 3x plus 11, and then notice I'm subtracting the 2x plus 8. So we do have to distribute that negative, right? That minus sign applies to 2x and 8, applies to everything in this numerator. So I'm doing 3x plus 11 minus 2x. Some people will do this and adjust the signs, plus negative 8. And then we can just consider this addition now that we've applied the negative. So 3x minus 2x would be just 1x. And then 11 plus negative 8, 11 minus 8, would be 3. Okay, so if we write our simplified answer, we have x plus 3, that's a binomial, over x plus 3 times x plus 4. So we see that we get a common binomial factor of x plus 3 in the numerator and denominator. So because this divided by itself would reduce to just 1 over 1, my simplified answer that I could write would be 1 over x plus 4. So both of those examples had common denominators to start with, but the denominators will not always be the same. So let's look at a couple of examples like that. So if the denominators are different, the way we need to begin is by getting a common denominator, what we call the least common denominator, or LCD, least common denominator. And it's essentially the product of all of the factors of our denominators. So in order to identify our LCD, we need to factor all of our denominators. Okay, factor the denominators. So for this first denominator, x squared minus 4x, there is just a common factor of x. And if I factor out an x, I get x times the quantity x minus 4, right? I undistribute the x. This second denominator is just a single x already. So my least common denominator, both of them need to have the same denominator, including all of the factors. So I see that the second rational expression does have the x part of the denominator. It does not, however, have the x minus 4 part of the denominator. So what I'm going to do in order to make it have that in its denominator is I will multiply by the factor I need in my denominator, in this case x minus 4. Now the rule with fractions, in order to do this for this least common denominator, we multiply on the numerator and denominator. So what we multiply in here has a value of 1. So I'm going to distribute my 2 to the x and the negative 4. So that will give me, let me rewrite our problem down here. Actually, it's good to come down here and to rewrite your least common denominator, because we have to start there. Once we determine that least common denominator, we will leave it alone. So we have the 8 from our first rational expression, and then in our second one here, now we have plus 2x minus 8. So we can see the like terms of 8 and negative 8, which just make 0. So in my numerator, I have 2x, and in my denominator, I have x times the quantity x minus 4. All right. Now in this case, when I look for any common factors in the numerator and denominator, there is an x in the numerator and denominator. So this factor x over x would reduce to 1 over 1 when I divide it. So I can write the simplified answer here for this rational expression as 2 over x minus 4. Not every addition and subtraction problem reduces at the end, but sometimes they do. And so these are some of the things to look for. All right, now this next one, notice that we are subtracting, right? It's 7x plus 2 over x squared minus 3x minus 4 minus 6 over x minus 4. So a good thing to do is to go ahead and apply that negative to our second numerator. In this case, that's just the number 6. And then just make this an addition problem. What that does, it applies the negative. We didn't get rid of it. We just multiplied it into this numerator, basically, to now make this an addition problem. And now as we work the question, the negative will take care of itself because we put it on the 6. All right, so remember we have to factor the denominators to find the different pieces of the denominators, all the different factors. Now this denominator is already factored, x minus 4. So when I factor this one, this trinomial, x times x gives me x squared. And then the two numbers that multiply to negative 4 and add to negative 3 would be negative 4 and positive 1. Right? So we know that least common denominator, again, we want the denominators to match, to have all the same factors in them. So both of them already have an x minus 4. We can see that. But this first fraction, this first rational expression also has an x plus 1 factor, and our second fraction does not contain that right now in its denominator. So remember, when one of our fractions is missing a factor in its denominator, we multiply that factor. Oops, I saw the 6 and wrote a 6, but it's an x. Okay, we have to multiply by the factor over itself onto the fraction that is missing that. Okay, so now I'm going to distribute the -6 to x and to 1. So that's going to give me, let's look at our numerator. So I have the 7x plus 2, and then -6 times x is -6x. -6 times 1, move this up, would be -6. So then I can combine like terms. 7x minus 6x is 1x, and then 2 minus 6 is -4. So I have x minus 4, the binomial x minus 4. And again, as I look at my denominator, remember we can only cancel factors, not terms, but since in my denominator x minus 4 is a factor, and in the numerator essentially I have 1 times x minus 4, that's a factor, I can reduce that. That reduces to 1 over 1. And so I could write my simplified answer as 1 over x plus 1. So for our last two examples here, we're going to look at two fractions where their denominators are just completely different. They don't have anything in common at all, no shared factors. So we want our least common denominator, again, to contain all of the unique factors of our denominators. So this denominator is x plus 2. So I'll need an x plus 2 factor in my LCD. And then this denominator is x minus 5, so I also need an x minus 5 factor in my LCD. So since my least common denominator needs to be these two factors multiplied together, I just, again, go back to each fraction and identify which part of the LCD it is missing for it to match this. So it has the x plus 2, but it does not have the x minus 5 factor. So I need to multiply my first rational expression by x minus 5 over x minus 5. So that would be 7x, again I'm distributing here, minus 35. And then for my second fraction here, notice I'm subtracting. So remember, a good way to do that would be to move that negative onto the numerator, that second numerator, and then now consider this addition. Adding a negative is the same as subtraction. And then this second fraction has the x minus 5 portion of the denominator, but it does not have the x plus 2 factor of the denominator. So I will multiply it by the factor it needs to match the LCD. And again, I'm going to distribute, and I'm distributing the -4, right? I made that a negative to address the subtraction. So distributing, that becomes -4x minus 8. So now I can combine like terms in my numerator. So 7x minus 4x would be a positive 3x. -35 minus 8, or plus -8, would be -43. And then my denominator I keep in its factored form. All right. I cannot factor 3x minus 43. There's no greatest common factor, and I see no matching factors in the numerator and denominator, so that would be my final answer there. Okay, one last example here. It's similar to the one we just did, where I've got two denominators. They're both different. So my least common denominator just needs to be a combination of the two. So it needs an x plus 3 factor, and it needs an x minus 5 factor. So in order for each fraction to have a matching denominator, I will multiply it by the factor it's missing. So this first fraction has the x plus 3 factor, but it's missing the x minus 5. So I will multiply by x minus 5. Now in my numerator, I'm going to distribute this out using FOIL, using distributive property, and that's going to become a quadratic. Right, so I would get x squared minus 5x minus 2x plus 10, which you could go ahead and condense this to a -7x if you like. We're going to have to combine all our like terms anyway in just a moment when we do the second one. So the second fraction has the x minus 5 factor. It's missing the x plus 3 factor. So I need to multiply the second rational expression by x plus 3 over x plus 3. So again, using the distributive property, or FOIL if you use that abbreviation, when I multiply this out, I'll get x squared plus 3x plus 4x plus 7. Okay, so now I can take a look at all of my like terms and see what I have. So there's 1x squared here and another x squared here. Those are like terms. So I can combine that. That's 2x squared because there's 2 of them. All right, next let's see. So my negative 5x, negative 2x is negative 7x. And my positive 3x, positive 4x is positive 7x. So that's all going to cancel out because negative 7x plus 7x is 0. So I just have left 10 plus 7, which is 17. So I have 2x squared plus 17. And that is over my least common denominator in its factored form, x plus 3 times x minus 5. No common factors in the numerator, no common factors to reduce, so that is my final answer.